But nothing too crazy today. So rational expressions. I really love the word rational. It's just a fancy name for a fraction. So 1,4a really, of course, is anything and everything to do with fractions, meaning we're going to add them, subtract them, multiply them, divide them, and simplify them. Sounds very crazy, but it really boils down to a lot of factoring and crossing stuff off. So if you're good with factoring, this is super simple. So a fractional, I think I said fraction enough, expression in which both the numerator and denominator are polynomials. So much good vocabulary. So as you can see, of course, here's some examples of some rational functions. We have our polynomials, top and bottom. We're going to be working on simplifying those types of expressions, adding, subtracting, multiplying, dividing, all this stuff too. A lot of factoring. All right, we're going to also talk about domains because fractions do get a little tricky sometimes on the domain, meaning domain, there's a throwback vocab word. Domain is what you can put into the function. The values for x you can plug in there and get an answer. Well, the only time you have to be a little concerned about it is we all know you can't divide by 0. 0 under the line is undefined. So when I'm looking at domains, I'm really focused in on the denominator on these fractions. So the domain, let's first start with the blank here, the set of all real numbers that the variable is permitted to have. So like for instance, when I look at this, I was like, ooh, I can't have 0. 1 over 0 is undefined. Not going to happen. Here, I have to be greater or equal to 0. I can't use a negative number. If you try to square root -4, it kicks us into the imaginary unit system. And then same thing here. I can't square root a negative number, and I can't have 0 on the bottom because that's an undefined fraction. So that's really when we talk domains, we're going to do a couple of these that you're really worried about is what numbers make the bottom 0. You can't use them. 0 under the line, undefined. Now, I gave you something that's super easy. A. It's not a rational expression. It's just a plain old boring quadratic. So if you graph it, it's that parabola that will cover all the way to the left, all the way to the right. All of the x values will work. Plus, I'm like, I can put anything I want in here for x. I can square a negative, a fraction, a decimal, you name it. I can square it. I can multiply by 3. I will get an answer. I can use any real number, and I'm just going to use the symbol for it. I put anything I want in there for x, and I will get an answer out. Now, these are a little tougher because you have the fractions. So 0 under the line, undefined. So first thing, I don't care what's on the top. I'm worried about the bottom. I think it's going to be easier. Everything comes back to factoring. If we look at the trinomial in factored form. So multiply to 6, add to -5. I'm just going to underneath just quick write the factors. So I'm just going to start with that. Now, super, super easy. I'm just thinking about what numbers 0 out the bottom. Well, this one, 3 is going to be an issue because you're going to have 3 minus 3, 0. 2 is going to be an issue because that would also make the denominator 0. So I can use any real number my little old heart desires except 3 and 2. Now, just to practice, thinking about your quiz tomorrow, let's write that out in set builder notation. This is a throwback to the very first section. X such that x can equal 3, x can equal 2. Everything else will give us an answer. All right, let's look at this guy. So I do have a couple concerns on this one. Let's start with the easy, the bottom. What number can I not use in the denominator? 5. Because you'll have 5 minus 5, 0, 0 underline. And we do have a little glitch on the top because you have square root. What numbers did we say you can't square root? Negatives. So I also need this to be 0 and above. So I'm going to write out all these lovely little mental notes here to practice set builder form. X such that. Let's do the x can equal 5. And I'm running out of room. I'm just going to sneak it underneath here. And we also have to be greater than 0 or equal to it. So just practicing what you can put into the function. So just a couple questions on the homework about domains. We do talk about domains more and more throughout this class, but just kind of getting us started. Now let's get to the simplifying. where we can practice our factoring. I love this stuff. So, factor both the numerator and denominator and use the following property of fractions. Two things to point out to you. Notice really dramatic emphasis here. You have product between those, not addition or subtraction. You're multiplying those together. And if you have this common factor, C over C, of course it's a fancy form of 1. We can just cancel it out. So here's what we're going to fill in on the blanks, what we're really after. You can cancel common factors. So really the rest of these problems, except maybe the last couple, I'm going to factor as much as I possibly can factor, and I'm just going to try to cross off common factors. That's what it's going to boil down to. That's why I said this is kind of, a good one to do. Practice our factoring skills, which are obviously on your quiz tomorrow. We're just using them today. So I'm going to try to factor right away. I can't try to cross anything off right now because I have addition, subtraction in there. Remember, we need them written in product form, hence the factoring. So I'm going to factor out the top, difference of perfect squares, x plus 1, x minus 1. Here's a good review. And then I'm going to factor out our bottom trinomial. What multiplies to -2 and adds to 1? Well, 2 and -1. So you now have them in product form. So I'm going to cross off our common factors, and I'm going to jot down my final answer. Done. I know it doesn't ask for domain, but let's just practice. That's kind of new. What's the only number you couldn't use in your domain? -2, because it would 0 out the bottom. Got it. Okay, same thing. I'm going to try to factor. Look for the common factors, cross them out. Now the bottom's kind of nice because I kind of factored it for us a little bit. I can't do a lot there. But that x squared minus 1, let's factor that. X plus 1, x minus 1. So I'm going to, of course, cancel out the x minus 1s. And you could reduce one other thing. I wouldn't leave 4 over 12. What's 4 over 12, really? 1/3. I'm not even going to bother writing the 1. I'm just going to leave x plus 1 on the top. Let's put the 3 down here. And sometimes I get asked, like, do you need to distribute the bottom? Should I make it 3x plus 6? Well, let me ask you this. Is this form and 3x plus 6 really the same? Are they the same? Yeah. So do I care? No. So I'm not going to do any extra work. If you want to make it 3x plus 6, I mean, be my guest, but I'm going to leave it right there in factored form. All right. Oh, fun. Let's kick up our factoring. Good review. Sum of perfect cubes. So great, so great. So we're on the top one, the purple one over there. First I figure out, maybe you know it, what number cubed is 64? 4. So I'm thinking about that as 4 cubed. So factor perfect cubes. Easy factor, binomial, take the cubes off. X plus 4. And then remember your second factor is that trinomial. So we've got over there in our formula a squared, or I'm going to square the first term. We have to reverse our sign, so plus goes to minus. I multiply x and 4 together. I'm not going to put x4, I'm going to make it 4x. Last sign's always a plus, and then we're going to square the 4. Not a room. Okay. Now, the denominator, I think we could probably factor on that. Also, of course, trinomial lead coefficient 2. Now, I know some of you just kind of guess and check it and do it that way. Totally fine. I know we're going to have a 2. Now, let me give you a pro tip here. And we can go through all the factoring methods, of course, again, but I'm going to kind of work smarter, not harder. So I'm guessing there's going to be like something in here that crosses off, right? That's our whole goal here. Clearly, I'm not going to have another x squared minus 4x plus 16. So I'm pretty sure this guy is just going to be x plus 4 would be my pro hunch on that. And then I'm just quote unquote kind of unfoiling this in my head. 2x squared, 8x. Oh, I'm going to need minus 1 to get to a 7x. So that's sometimes how I kind of cheat the factoring, as I look for a common factor up top and kind of use that to help my cause. So we can get rid of those. Okay, x squared minus 4x plus 16 does not factor anymore, so we're just going to jot it down. My sloppy plus there, and then 2x minus 1. Yeah, so good review of the perfect cubes. Like I said, that's probably the only thing you need to quote unquote memorize, study, etc. You have to know how to factor cubes for your quiz tomorrow. Okay, multiplying and dividing. Now, it's really more of the same, this more work, which makes us super happy. Remember, when you multiply fractions, you multiply straight across. So I'm going to multiply the numerators together, the denominators together. But I don't want to get crazy and distribute and FOIL it all out and make some giant polynomial, because we're looking for common factors to cancel. So I always factor as much, you're going to hear me say factor like 50 times a day. We're going to factor as much as we can and look for our common factors to simplify. So I'm not, if I distribute this out, it'd be a giant mess. We'd have a million terms. It'd be disgusting. So we're going to try to factor everything we can. See if we can maybe cross some stuff off. Okay, like our trinomial here, easy. Multiply to -3, add to 2, 3 and -1. Doesn't matter what order you look at all the expressions, we're just going to look at them all. I'm going to do the bottom here. Multiply to 16, add to 8, 4 and 4. Can't do a lot to 3x plus 12. I can pull a 3 out at the very least. So I'm going to take your greatest common factor, a 3 out of that. And x minus 1 is what it is. There's no GCF. Wish it was perfect squares or something, but no such luck. Okay, so now we're looking for the common factors. Now, technically, I mean, we're multiplying this together. I'm thinking about this all as one giant numerator, one denominator, one giant fraction. I'm looking for my common factors in the top and the bottom. What else can you get rid of? Got it. So final answer, x plus 3 over x plus 4. So I know sometimes it's tempting to distribute or FOIL all of that stuff together, but it's going to make it a giant polynomial on the top. Try to factor. Did I miswrite it? Oh yeah, I forgot the 3. Yeah, I got so excited about my factoring talk because I'm so excited about my factoring. So try to factor as much as you can and cross things off. Always work on smaller expressions. That was my spiel there before I got distracted by the 3. Okay, more of the same, really, but ooh, we're dividing. When you divide two fractions, we know old school 6th grade math here, we are going to multiply by the reciprocal. So that means the second fraction, we're going to flip it. Now, I'm going to write out way more work here than you're ever going to write out on your homework, but just to show you on the first one. So we're keeping the first fraction. Yeah, I know we can factor. And we're flipping the second. Can you factor this and flip it all right away? Sure. Typically, I probably would write this step. I would just start on the factoring and get after it. So x minus 4, no GCF. X squared minus 4, good review, perfect squares. What number squared is 4? 2, so x plus 2, x minus 2. Nothing to cross off yet. Okay, let's try this trinomial. Multiply to 6, add to 5. 3 and 2. I'm going to try to write small to sneak it in. And then multiply to -4, add to -3. -4, and I'm going to put it underneath. I'm running out of room. All right, let's look for our common factors we can get rid of. Well, x minus 4. What else can we get rid of? X plus 2, which I had to sneak mine on at the end here. Anything else? Okay, so just jot down what you have left. So the only thing we have on the top is the x plus 3. We've got our x minus 2 down here. And of course, at the very end, I had to sneak it on down there. You've got your x plus 1. All right, we're factoring. Okay, quick question. What's your domain? You could use every number except what? 2 and -1. Good deal. Any questions on dividing? All right, and like I said, on your homework, I don't expect you to write out this first group of work. I never write that out. I just factor and I know I flip it and go right to this part, and you can too. You can too. All right, adding and subtracting. That, of course, is everybody's least favorite fraction operation because you have to make a common denominator. So this does take us a little bit more work. It's a little more, shall we say, dicey. So use the LCD, least common denominator. Find this first, of course. I know we're shocked what word I'm going to say here. By factoring, So, like I said, I think I said factor like 50 times already today. So if you're like, I don't know how to start it, factor. We're going to factor. We're going to factor each denominator. We're going to take a look at the factors, and we're going to make our denominators match. That is the key. Anytime you have to add or subtract fractions, it is just more work. So here we go. Now, looking at the bottoms, x minus 1, x plus 2. There's no factoring to do in either, so that's not really helping me, to be honest with you. So what I'm going to do is I just want to make each fraction have the same denominator. So I'm going to use each expression, meaning first fraction has x minus 1 in it, so guess what? This one's getting an x minus 1. But of course I have to multiply it to the top also, because you're really multiplying by a fancy form of 1. So I'm changing the look of the fraction, not the value of it. And then of course the second one has x plus 2, so we're going to put x plus 2 on this one. I'm going to sneak it in there on the side. Okay. Now, operations. Adding, subtracting, multiplying. We have a lot of operations in here. Multiply, add, multiply. PEMDAS, GEMS, whatever you want to use. Am I adding or multiplying first? Multiplying. So I'm going to start on the multiplying. I'll do the adding after I multiply. So I'm going to do 3 times x, 3 times 2. Up to you if you FOIL out the denominators. I don't care one way or the other. I just care that those match. I'm just going to leave them as is. I usually leave them as they are because there might end up being an x plus 2 or x minus 1 in the top we could cancel at the end. But the tops, of course, I got to distribute x and x. X times negative 1. I'm just going to fill in the bottom. So we've achieved that goal of the common denominator, so just go ahead and fill in your x plus 2, x plus 1. Like I said, you could FOIL it if you want, your choice. But the purpose is having, of course, that very lovely common denominator. Now you can add any like terms together in the top. I'm going to put them in order too. Only x squared is, well, x squared. I'm going to put my x's together. 3x plus negative 1x, got it, 2, and 6 is just hanging out. Now, last thing I'm going to do, of course, before I circle it, is just check to see, are there any common factors in this we could cross off? Does anything multiply to 6 and add to 2? No, not. But I'm going to check it. So adding and subtracting always is a little more, because you got to make that common denominator. Now, I'm looking at this. I'm like, oh, okay, all right. I could get crazy and do like the last one and put x squared minus 1, x plus 1 squared. But I think we can work a little smarter and make less work for us. Because this x squared minus 1 does factor. So I'm going to think about it in its factored form, because I think we'll be able to get away with less work here. You could write this out twice if you want, but I don't know, that seems like extra work. So I'm going to try to make these match. So the first one has an x plus 1 and an x minus 1. Clearly the second fraction is missing an x minus 1. So our denominator on the second, we're going to have x plus 1 squared, x minus 1. We're going to have a lot of stuff in it. What are you missing on the first fraction to make a match? You need another what? X plus 1. Oh boy. I should have spaced this out more. So our common denominator, it's a hot mess, but they're going to match. We're going to have x plus 1 squared and an x minus 1. Whew. Okay. Of course, we're going to multiply before we subtract. So I like this. I mean, 1 times x plus 1. For the sake of writing, I am going to combo these x plus 1s as a squared, so I don't run out of room. On the right-hand side, well, we got 2. That's not the worst case, but we do need to distribute it through or multiply it out. And of course, the denominator, x plus 1 squared, x minus 1. Okay. So we achieved our goal. It's kind of a hot mess on this one, but we achieved our goal of our common denominator, so I'm going to fill that in. I feel like I've written it 20 times now. And now we can combine any like terms on the top. So I'm going to do the x's. 1x minus 2x. 1 minus negative 2. What's 1 minus negative 2? 3. Fortunately, no x, negative x plus 3 on the bottom to cross off. That big giant mess of stuff is our final answer. So adding and subtracting is the worst because you do have to go through and get the common denominator. Just time consuming, time consuming. All right, last thing we're going to do with these fractions today. Get yourself ready. It's just more of the same, really, just written different. We're going to talk about what's called a compound fraction. A fraction in which the number, the denominator are both, of course, fractional expressions. It's every favorite F word today, fractions and factoring combined. Now, this clearly is an example of a compound fraction. You have a fraction, x over y, and a fraction, okay? It's just a giant fraction nightmare. So we do need to simplify this. So of course you can see my pro tip up here, I would combine the numerator first, then work on the denominator and see where we're at. So I'm going to work on just the top here. I'm going to do this guy in blue. So if I'm going to add those together, adding fractions, common denominator. So one, I'm thinking about it, okay, it's y over y. So I'm going to have my common denominator y. On the numerators, x plus y, and I really can't do anything with that, but just write it down. I'm going to kind of do the same thing on the denominator. I'm going to do that one in red. So of course, I'm thinking about the 1, fraction form, common denominator. 1, of course, is equivalent to x over x. So common denominator, x, top x minus y is what it is. So now you're dividing fractions. Okay, all right, we know how to divide fractions. You multiply by the reciprocal. So the top blue one just stays as is. I'm going to change this big blue division fraction bar to multiply and reciprocal. So let's take a look at that. Does anything cross off, reduce, cancel? No, I feel like we did a lot of work and we really didn't get a lot out of it, but it is what it is. So I'm going to jot down the top. It's up to you if you want to distribute the x through. I'm just going to put the x in front, x plus y. Same on the bottom, I'm going to leave the y. I really was kind of hoping these would match so we could cross them off, but just not the way the cookie crumbled today. And there we have it. So these, little tricky because it's all the fraction operations in a problem. Adding, subtracting, dividing, we got it all. So let's do another. So, well, the bottom's not bad. I'm not offended by the bottom. I mean, h is h, that's pretty easy. We got to work on the top though. I need a common denominator. Unfortunately, I can't just do like plus h to this because remember you're multiplying. So I'm going to use each expression. The left has an a plus h, so the right's getting an a plus h. The right fraction's just plain old boring, simple single a, so I needed a little simple single a. I'm just going to leave the bottom for right now. So working on the top, of course. Top's the mess. So I'm going to multiply first, a times 1, a plus h. Up to you if you distribute them or not. I just care that they match. 1 times a plus h. I like that. In the bottom. So just looking at those top two red fractions, we do have our common denominator, so we can go ahead and combine those. Again, I'm still over h is just hanging out on the bottom right now. Haven't really done anything with it. But let's work on the top. We've got our common denominator, so I'm going to fill it in. And what's your numerator up there? All that's left is negative h. A minus a cancels, and then you're subtracting h. Okay, still a fraction within a fraction. It's still a complex fraction, but we can divide it out now. Because the top's in fraction form, I'm just going to get dramatic and put the bottom in fraction form. When we divide fractions, you multiply by the reciprocal. Okay, all right. So I'm going to keep the top red. A plus h, got it, times. And I'm going to do the reciprocal on the bottom purple. So I'm going to flip it and make it 1 over h. Oh, man. We did all of that work to only be able to reduce really one thing. What are we reducing? Yeah, I hear it. The h in the top and bottom. God, that's depressing. So all I have left is negative 1 and the a plus h. Whew. It seemed like a lot of work just to take out a dumb h at the end, but we simplified it some, I guess. All right, let's do one last one of these. And the reason I threw this one on, really, it's more of the same, is because you have some fraction exponents in there. So we can kind of practice that for your quiz tomorrow. Okay, so the top, let's look at the top here. Let's see if we can simplify this a little bit. So of course I'm going to factor here on this one. So I see we've got these 1 plus x squareds in common. So I'm going to take some of that out. The question is, how many? Are you using the positive 1/2 or the negative 1/2? Negative. You always take the smallest amount. Good work. Again, this is really just on here to review for your quiz tomorrow. Okay, so that's our GCF to get our first term back. Clearly I need some more of these 1 plus x squareds. The question is how many? You took negative 1/2 out. How many more do you need to get to positive 1/2? 1. 1 minus 1/2 is 1/2. For dramatic emphasis, I'm going to put the 1. Clearly, I'm going to need a longer. Okay. So we took the 1 plus x squared to the negative 1/2 out, which I'm writing all over it. So all we need left, of course, is the minus x squared. And I'm just filling in the bottom. And I probably have too long of a fraction right here. Let's erase this. I'm going to run out of room. All right. Now, to the first power inside. Like, I feel like this inside we can clean up a little bit. That's what I'm going to work on. Because to the first power doesn't really affect anything. It's not like I got to FOIL it or anything. So if you clean this up, I really kind of like it. What's left in there? 1, which I'm not really sure is worth me writing, but there it is. Okay. I don't know why I'm putting this in parentheses. I'm just going to write 1 plus x squared. Because of course, ignore the parentheses to the first power. Your x squareds are going to cancel. Got it. Now, who cares about the 1, right? Let's say, thinking about your quiz tomorrow, it says in the directions, no negative exponents. Well, we can handle that. We're going to have to put this where? On the bottom. So that becomes a positive 1/2. And I'm going to just fill in this other 1 plus x squared. Now for dramatic emphasis, I'm going to sneak it on, that's to the first power. Since these are the same, can I simplify and total up how many of them we have? Yeah, what's 1/2 plus 1? 3 halves. This is so messy looking. Bothers me. Bothers me. 3 halves. Got it. Now, I mean, I'm getting carried away thinking about your quiz here. What if it also said in the directions, you can't have fractional exponents in the bottom, and you had to rationalize it? How many more of these do you need to get to a whole number? Another 1/2 of it. So it just depends on how crazy the directions are. If it just says no negative exponents, move it, call it good. If it says no rational exponents in the bottom, of course, then I would go further and handle that too. Okay? So any questions on that? It doesn't say